Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to start with a new quiz of different variety of questions from topics like Met, REGS, NAV and Tech. So let's start with today's questions. Question number 1. An aerodrome reference point is defined as what? Is it pre-flight altimeter check location, location of landing threshold, designated geographical location of the aerodrome, deviation elevation of the highest point of landing runway? So out of this all options, the correct definition of this point is aerodrome reference point. It is the designated point or designated geographical location of the airport or aerodrome. So that is your aerodrome reference point. You have to remember this definition: designated geographical location of the aerodrome. Okay. Next, question number 2. ISA specifications for mean tropopause conditions are what? So according to ISA, what is the mean temperature and height of tropopause? So according to ISA, so here you can see, first we have, let's take, this is our earth. Okay, this is our earth. Over here you have your north pole. Over here you have your south pole. Okay, now the thing about the height of tropopause is that it varies with latitude, seasons, day and night temperatures, as well as the amount of insolation. Okay, so at equator, okay, at equator where we have maximum amount of insolation, low latitude, okay, lots of land area, over there we have tropopause extending to a height of approximately 16 kilometer. Okay, so that is very high. At poles where there are cold temperatures, high latitudes, winters, 6 months night time, so over there the height of tropopause is just 10 to 11 kilometer approximately. So if we draw this diagram, the height of the tropopause will be somewhat like this. As the latitude increases, the height of tropopause also increases, maximum being at the equator, then decreasing again, minimum being at either pole, north pole or south pole. Okay, same thing over here. It goes on increasing, maximum being at the equator, then goes on decreasing to minimum being at the south pole. Okay, so at equator, the tropopause will be at equator, tropopause, which is the maximum height or the last limit of the troposphere in the atmosphere, is called tropopause. So over here the tropopause will be at its maximum height. At poles the tropopause will be minimum height. Okay, so it all depends on latitude, seasons, day and night, amount of insolation. Okay, so will be minimum at poles. Okay, the height. So you have to remember these 2 points. Now according to ISA, we have temperature lapse rate of 2 degrees Celsius or approximately 2 degrees Celsius every 1000 feet. The accurate value is 1.98 degrees Celsius every 1000 feet. So as you climb every 1000 feet in the atmosphere, the temperature is going to drop by 1.98 degrees Celsius every 1000 feet. But there is a limit to that. At 36,000 feet, 36,090 feet, 36,090 feet, this lapse rate of fall in temperature with increase in height will stop. Okay, so temperature lapse rate is what? Your temperature lapse rate is, just a second. Your temperature lapse rate in ISA is 1.98 degrees Celsius every 1000 feet. Okay, 1.98 degrees Celsius every 1000 feet. So, as you climb in the atmosphere, okay, this is your height, vertical axis is your height in the troposphere, T is your temperature. So, as you climb, mean sea level temperature in ISA is 15 degrees Celsius. So then as you climb in the atmosphere, this temperature goes on decreasing at the rate of 1.98 degrees Celsius every 1000 feet. Okay. Then there comes a particular height, a height of 36,000 feet. Okay. A height of 36,090 feet, where this drop in temperature at a particular lapse rate stops. Beyond that, this lapse rate stays constant, that is 0. Okay, it doesn't drop and at all, the temperature doesn't drop. Whatever the temperature is at 36,090 feet, that remains constant up to the height of approximately 65,000 feet. And that temperature is, which you have to remember, is minus 56.5 degree Celsius, minus 56.5 degree Celsius. Okay, so two things we covered. Mean sea level temperature 15 degrees Celsius. It drops at the rate of 1.98 per 1000 feet. At 36,090, the lapse rate stops. The temperature achieved at that height is negative 56.5 Celsius. Beyond that, it stays constant at minus 56.5 degrees Celsius up to the height of 65,000 feet approximately. So the correct option here will be for mean tropopause, because we have tropopause height maximum at the equator and minimum at the poles. So the mean of that, the average of that will be 36,090. So option A, and minus 56.5 degree Celsius. Question number 3. Aircraft is at 8,000 feet. Ground station is at mean sea level or ground level. What is the range at which a pilot can expect a QTE from the ground station? So, in the VDF chapter, actually, there are 4 Q codes. 4 Q codes for direction finding. So, first one is QDM. Okay. Second one is QDR. So, QDM is magnetic bearing to the station. QDR is magnetic bearing from the station. Next two Q codes are QTE, QUJ and QTE. Okay. So Quebec Uniform Juliet, Quebec Tango Echo. So QUJ is true bearing to the station. QT is true bearing from the station. These are the 4 Q codes that you will find in the Radio Navigation Oxford book of VDF chapter, very high frequency direction finding, and in that there is this given 4 Q codes that you have to remember. Next thing is we have to calculate QTE. So here you have QT, the meaning of QT is true bearing from the station, true. So remember these 4 Q codes for your DGCA MCQ. Next we have to find the range. Now there is a direct formula for this. The range is equal to 1.25 into square root of h1 plus h2, where h1 and h2 stand for aeroplane height, ground station height. So over here, let's substitute the value 1.25 into square root of H1 is 8,000. So 8,000 plus H2 is ground station height. So ground station is at mean sea level. Okay. Ground station is at mean sea level. So what is the range at which a pilot can expect his QTE from the ground station? So accordingly, we will put 0 in place of H2. Let's open the brackets. So 1.25 into square root of 8,000. Use your scientific calculator. It is equal to approximately 89.5. Multiply both of them. 1.25 into 89.5 is 111.8. So approximately 112 nautical miles. The answer you get is in nautical miles directly. So the closest option is option number Bravo, 107 nautical mile. Okay. So square root of 8,000. Again, let me check. 89.5 multiplied by 1.25. Yeah, it is 112, approximately 112 nautical mile. Now, in some textbooks, this formula has 1.23 square root of H1 plus H2. Okay. So there won't be much difference in your final answer because 0.25, 0.23 is negligible difference. Okay, so this is the formula. Substitute the values, multiply carefully, and then find the closest option, or sometimes you also get accurate option in the question. Let's go to question number 4. This is your direction finding test. So very basic question just to check your direction orientation, sense of direction. Now over here, Boeing is to the east of Airbus. So let's say always whenever you draw diagrams, always mention the basic northerly direction on the top of the page. So that if this is north, that will be that direction will be east, that direction will be west, and the downward direction will be southerly direction. So automatically the reader or any student or anyone who is reading your work will come to know the direction sense. Okay, so this is your northerly direction. Now we have been given first statement, Boeing is to the east of Airbus. So we have a Boeing aircraft somewhere here, and it is to the east of Airbus, means Airbus is to the west of Boeing. So I'm drawing Airbus over here. Okay, next question, next statement is Airbus is in the north of ATR. So we have Airbus and it falls to the north of ATR. That means ATR is to the south of Airbus. So I'm writing ATR over here, south of Airbus. Let's check the next statement. Cessna is to the south of ATR. So we have Cessna which is again to the south of ATR. So this is your north direction. So south will be opposite direction. So Cessna is here. The final question is, which direction of Boeing is Cessna located? So from Boeing, starting from Boeing, you have to measure the direction starting from Boeing at which Cessna is located. So this is your south, this is your west, this is your east. So from Boeing, Cessna is in the direction between south and west, right? Boeing falls in the direction between south and west from Boeing. So our final answer will be from Boeing. The direction of Cessna is southwest direction. It is southwest direction, correct? So Boeing is to the east of Airbus. ATR is to the south of Airbus. Cessna is also again to the south of Airbus. But with respect to Boeing, Cessna is to the southwest of it. So correct option will be southwest. Option number Bravo. Let's go to question 5. A steady green light from ATC. Two aircraft on ground. So this part of the question is very important. There are two scenarios. Aircraft can be in air, aircraft can be on ground as well. So over here aircraft is on ground and you are getting a steady green light from ATC directly. So what does that mean? So this is a part of regulations and you have to remember this table by heart for your for any written exam that you take, and as also for your SPL student pilot license Viva exam. These questions are also asked in check rides, private pilot check ride, instrument, commercial. Okay, this question can also be asked in airline interviews or airline written exam. So this is very important question. So over here, as with respect to this question, we are on the ground, so focus on this column, the ground column. So when you get steady green light from ATC and you are on the ground, that means you are cleared for takeoff. You are cleared for takeoff. So the correct option will be green light on aircraft on ground, cleared for takeoff. Now let's look at other lights. Flashing green, cleared for taxiing. Steady red means stop wherever you are on ground. Flashing red on ground means taxi, clear of runway in use, means go out of the runway or exit the runway in use, exit the runway. Flashing white is to go back to the starting point of the airport. Okay, alternating red and green, which is common to both aircraft on ground and aircraft in air, means exercise extreme caution. Next, when you are in air and you get steady green light, that means you are cleared for landing. Then flashing green means return for landing. Steady red means give way to other aircraft and you continue circling or holding wherever you are. Flashing white is not applicable in air, and alternating red and greens means exercise extreme caution. Okay. Now, flashing green will always be followed by steady green. So flashing green will be given to you first, which the message, what is the meaning of that steady flashing green light is that you will be directed towards the airport. And once you come towards the airport and you are aligned with the runway and you come down for approach and landing. So when you are in for landing and very close to the runway, you will receive landing clearance. But since you don't have radio equipment or functioning radio equipment, you will be given a steady green light, which has the meaning of cleared for landing. So flashing green will always be followed by a steady green. Okay, so this also can be a potential MCQ question. Remember this. Question number 6. The formation of a thermal. Thermal means anything related to heat. Low pressure is by what? So thermal low pressure is created in the atmosphere by what process? Is it by a dynamic effect, advection of warm air, advection of cold air, or a temperature increase? This is temperature increase in an area in relation to surrounding environment. So what is the correct option? Now, a quick thing, small concept. Now whenever we have this sun in the atmosphere, okay, during daytime, so whenever we have this sun, depending on the season, latitude, the topography, our land will be heated by it. Our land will be heated by that sun. Thing but the insolation process, okay, the reception of sunlight or heat from the sun on to the earth, which is insolation. Now when this sunlight or when we get heat from the sun during the daytime, this heat heats up the land surface, heats up the land surface on the earth. When the land surface gets heated up, the air layer which is close to the land surface, the layer of air which is very close to the land surface, a very small layer of air which is very close to the land surface, it also gets heated up due to contact with the ground. So a heated land will in turn heat the atmospheric layer of air which is in contact with it. And this transfer of heat from the land, this transfer of heat from the land to the atmospheric layer of air is due to conduction, is due to conduction process. Okay, it is due to conduction process, right? So next step. Next, when this layer of air is heated up, okay, when this layer of air is heated up, what happens to it? Its volume increases. Its volume increases, and volume and density relation is they are both inversely proportional to each other. Density equals to mass upon volume, right? So volume increases, as a result of which density of this air mass decreases. As a result, this air mass becomes light. Air mass becomes lighter than before, and the consequence of all these three things is that the air mass or the layer of air which gets heated by the ground becomes light, and as a result, due to light weight and less density than before, it rises up in the atmosphere. It rises up in the atmosphere as long as it gets saturated by the surrounding temperature or moisture. Okay, so it will keep on rising, okay, till it achieves stability. Okay, so this is how, due to conduction, the air layer gets heated up by the land. As a result, it becomes light. It rises up in the atmosphere, depending on the stability, instability of the atmosphere. If the atmosphere is very unstable, it will keep on rising and rising, and this we called this upward current of air. We, in that case, in unstable atmosphere, we call convective currents, updrafts, and this can create many clouds in the sky. Depending on how unstable atmosphere is, that type of corresponding cloud will be created. So this air layer, when goes up in the atmosphere, there will be created a void. I will write over here, a void in its place. So previously, before this air mass rose up in the atmosphere, it occupied this particular space near the land or close to the land, okay, or in contact with the land surface. When it rose up in the atmosphere, there will be created a void in its space, an empty space, okay, in the position which it occupied before, and that we call low pressure. That we call as low pressure. So we can, so in simple words, I told you, when this air mass rises up in the atmosphere, a void is created in its place, and that in atmospheric sciences or meteorology we call low pressure. So this is how a low pressure will be created in the atmosphere. So very first simple point, insolation, which is the transfer of heat from the sun to the ground. When the ground gets heated up, the air in contact with it which also will get heated up by conduction. As a result of which its density will decrease, its volume will increase. It will become light, okay, and as a result, this light object will rise up in the atmosphere, okay, up to a particular height, depending on stability or instability of atmosphere. And when it rises in the atmosphere, the place that it occupied before on the ground is replaced by a low pressure region, or we call that void or empty space as low pressure. And in this low pressure, there will be inflow of air. There will be inflow of air from surrounding regions. There will be inflow of air from surrounding regions, because this low pressure will definitely be surrounded by an environment of relatively or comparatively higher pressure. So there will be inflow of air or flow of air from any high pressure region surrounding it to this low pressure. And when this airflow reaches low pressure, it will be due to instability, or because when it reaches low pressure, at the place of low pressure there will be a heated ground or too much of heat. As a result, this airflow will, again, just like this airflow, it will also experience increase in volume, decrease in density, and it will follow the same procedure that when it comes towards the low pressure, it will rise in the atmosphere. It will rise in the atmosphere. Okay, so this cycle continues. The airflow goes up in the atmosphere. To replace it, the airflow from the top layer of the atmosphere comes down, or there will be airflow from surrounding areas. Okay, with respect to that low pressure region. So this is how the low pressure is created, and then the process that follows after the low pressure creation. So according to this question, the appropriate answer will be a temperature rise in an area in relation to its environment. So there might be a land surface, a very big land surface, which is barren, which is desert or anything like that. Okay. So, and this desert might be after long distances of kilometers surrounded by a forest. Okay. So in relation to that forest, this desert will definitely have a low pressure region on it, because this desert will get heated up much more quickly than the vegetation areas that it has in its boundaries. Okay. Of forest areas. Okay, so this low pressure created on this desert will have inflow of air from any surrounding region, which might be a sea, forest, or agricultural field, etc. etc. So remember, thermal low pressure is created in such a way. Next point, question number 7. Why are aeroplanes equipped with conducting tires? Okay, so it's a technical question. Why do we have conducting tires on landing gear of aircraft? So the reason behind that is for preventing sparks when they land on the runway. Now when aircraft land on the runway at tremendous speeds, the landing gear can create static electricity due to friction between the landing gear and ground surface. And to dissipate that, we have conducting tires to prevent sparks when they land on the runway. So remember this question, very important. So with this, we come to the end of this lecture. We come to the end of this quiz. I hope you have understood this lecture. You have learned something new today and you have liked this lecture. And if you have liked this lecture, do hit the like button. Let me know that. Subscribe to this channel so you keep getting new updates, new notifications time to time. And do share this video with everyone so that everyone benefits from it. Thank you for your time. All the best for your exams, all the best for your preparation, and do come in the next video. Thank you.